Hi everyone, I'm Michael Baldwin from the AAA Coat project. Today I am chatting with Alexander Perzon, Senior Material Scientist at Cellugy, one of our industry partners. Hi Alexander, nice to chat with you today. So
Hello.
start off, can you tell me about Cellugy? What does it do as a company?
So in simple words, we produce bacterial cellulose, and that is natural cellulose fibers. Most people know cellulose from plants and especially wood, for example, in paper making, where trees are cut down and the biomass is put through extensive chemical pulping, etc. But at Cellugy instead, we use a fermentation process to grow ultrafine cellulose fibers. So we use bacteria which in nature produce cellulose as part of their biofilm to produce a unique and natural material. And as we produce cellulose using a bottom-up approach like this, it gives us full control over the material properties in a way that you don't have when cellulose is derived from plants. I think that summarizes, what we do at Cellugy.
Okay, can you tell me more about how the company started? Has it been around very long?
It hasn't been. It's been around for a few years now. Cellugy was founded by Debbie, Isabel, and Parun, and their story is something like this: that they initially were very inspired by the bacterial biofilm that they saw. This is like a transparent sheet of naturally entangled cellulose fibrils, consisting of like 99% water, and amazed by this, they started out trying to make bioplastics that is completely biodegradable. And
Ah,
from there on, the company has grown, and I started back in 2021 as a material scientist. And at this stage, it was still a very early stage, setting up a lab. And since then, we have built a pilot plant and really ramped up our production.
yeah. I saw last year you moved into new premises.
Yeah, so we have moved into Søborg in outside of Copenhagen,
Uh,
where we have our pilot plant.
okay, super. All right. So can you tell me a bit more about the bacterial cellulose that you produce? What is it? What does it look like? What is it? And what properties does it have? What could it be used for?
Mm. So right now we are making gels, cellulose, so we're not making these films anymore, and we are aiming to use it as an ingredient in personal care products, such as hand creams, shampoos, soaps, and cleansers, to replace current synthetic and non-biodegradable polymers in these products. So many people are not yet aware of how much microplastics and non-biodegradable stuff are actually in these products. But the big companies within this area are becoming increasingly aware, and they are looking for green alternatives. The idea is to have an ingredient that can hold all these complex ingredients in these formulas, and cause it to thicken it without using any synthetic materials.
The company is also a partner in our AAA Coat project. So what is it doing in the project? What's its involvement?
Um, so in the AAA coat, we are using bacterial cellulose to coat material surfaces. So as bacterial cellulose naturally contains many reactive groups on the surface of the fibers, it opens up for several ways to functionalize it. So in this case, our partners in AAA coat are introducing antibacterial, antiviral agents onto the surface. So you can coat for example, the interior of public transport with something that could prevent germs from accumulating on the surface.
More about yourself. So you're a senior materials scientist at Cellugy. Can you tell us more about what actually that involves you doing day to day in the company?
So it involves a lot of different tasks. I mean, we are a small company, right? So
Mm.
everyone has to take on a lot of responsibility My core work is, of course, within R&D, from ideation to performing the tests, generating patents, and eventually, together with the commercial team, developing products. But I'm also working to continuously right now improve our quality control based on what kind of market we are using our material for, and occasionally also visiting customers as technical support. But luckily, I have a lot of good students in the lab helping out and so on. So I'm not alone doing all of this work.
And how did you yourself get into a research career, particularly now moving into industry? And I also wondered generally what inspired you to get into science when you're younger.
Yeah. So I was always interested in how things work. I have a lot of different interests. I would say I'm very, is the word multidisciplinary in that sense. But I think my favorite topic in school ended up being organic chemistry. You really get to know on a very detailed level how things work. And material science is, I think, naturally a very interdisciplinary topic, and therefore I think it suits me and it allows me to continuously learn new things. And I think material science in general is very cool in the sense that you start understanding why materials you see in your environment behave like they do. Like, why is something soft? Why is it sticky? Why is it hard? Why is it smooth? Like, in one way, it's very visual and requires a bit of imagination when you go down on the molecular scale and try to understand all these interactions. Yeah, and I especially enjoy the industry work here because it's gratifying to like see the direct impact of what you do, and it all kind of compounding into a product. And I think I really enjoy the teamwork as well, which I think is essential for the success of any company.
And what do you see as the future for bacterial cellulose over the next 10 to 20 years, say?
Yeah, I think in general, we need to be smarter with our natural resources, and being able to produce like natural cellulose fibers at scale will change things. I mean, with producing, I mean from a bottom-up approach using fermentation. Cellulose is, after all, one of the more versatile natural raw materials we have. It's used in many different products. And to bring that from like a crude material, which I consider it is the way we are using it, depending on what trees you grow and the location in the world and so on, and bring it into a more well-defined material, which is tunable as you grow it, I think it's going to change things, and it will definitely contribute less chemical waste, reduce deforestation, and also reduce the amount of plastics we currently use in our products.
That's all really very interesting. Thanks very much, Alex, for your time today. And yeah, we'll look forward to seeing you very soon in the next AAA Coat meeting. So thanks again for your time, and have a good day and all the best.
Thank you. It was a pleasure.